half reactions. When we're doing problems with half reactions, there are two common types. One is that you take two half reactions and combine them into one, which we will be doing tomorrow. Another one is taking a reaction and splitting it into half reactions, which is what we're doing today. And by the way, this goes with question number 25 in your book assignment, just so you are aware. Okay, the first thing we want to do when we do this types of reactions, well, first let's look at the question. It says, separate the following redox reaction into half reactions and label each half as oxidation or reduction. So you want to make sure that you're using like substances. So on this side, on the reactant side, we've got silver. So we're going to match it up to the silver on the product side. This is going to be one of our half reactions. And we're going to keep everything the same. So our coefficient, we're going to keep our charges, everything the same. So this is one half reaction. Then we're going to do the same thing for the second reaction, half reaction. Aluminum goes with aluminum. So right here we're going to put aluminum, and then on the product side we're going to put aluminum ion. Okay, now from here we just have to do what we've done before, and we have to look at our three viewpoints. Oxidation, remember, is gain of oxygen, loss of hydrogen or loss of electrons from the reactant side to the product side. Reduction is just the opposite. Reduction is if we lose oxygen, gain hydrogen or gain electrons from the reactant side to the product side. So now let's go ahead and let's compare. So on this one right here, we don't have oxygen or hydrogen on the silver, so we have to look at oxidation numbers. This has a +1. Remember, we don't look at coefficients at all when we're looking at if something's oxidized or reduced. So with this one is a +1 because of the charge. Silver right here is by itself, so this is a 0. This is what's known as its elemental form. So here this went from a +1 to a 0. That shows that we have gained electrons because we're losing them. And if we lose them, that's a negative charge. So remember, if it goes from a +1 to a 0, that number is being reduced. This is reduction because we're gaining electrons. So this one is reduction. Okay, now let's always check our second one just to make sure, because we don't want to make mistakes, because sometimes things happen and we have to double check. So in this one, we're going from aluminum atom to an aluminum ion. The aluminum on the left is in its elemental form, so it's a 0. On the right, it's in its monatomic ion, so it's a +3. So here, our oxidation number went from a 0 to a +3. It's increasing. Increasing an oxidation number means that we're really losing electrons, so this is showing oxidation because we have lost electrons. This one we have gained electrons. Okay, remember those electrons are pesky because they have a negative charge, and so it's kind of opposite of what you think, so think about the negative charge. Okay, so that's what your answer would be here if we make this look a little bit nicer. Okay, we're going to separate this out, so this is what this would look like. 3Ag with a plus charge goes to 3Ag. This one was reduced. It shows reduction. This one right here, our aluminum to our aluminum ion. This one was oxidized, or if you want to put reduction and oxidation, that's fine too. Okay, let's do another example. If you want to, you can pause the video at this point in time and do this one on your own, and then come back and check to see how you did. Okay, this one, same question. We're going to separate this redox reaction into half reactions and label each as oxidation or reduction. So again, let's do what's similar. Aluminum and aluminum. So right here, 2Al goes to 2Al3 positive. And then the next one, hydrogen and hydrogen, 6H positive goes to 3H2. Okay, so now let's look at our viewpoints. So the first one, we don't have oxygen or hydrogen, so we're going to have to do oxidation numbers. Remember, coefficients don't matter right now. So aluminum is by itself, it's in its elemental form, it's a 0. This aluminum is a monatomic ion, so it's a +3. Our oxidation number increases then this shows oxidation, and that's because we've actually lost electrons. If we lose something that's an electron which is negative, things become more positive. Okay, over here on the hydrogen half reaction, again, we can look at both viewpoints here. We can either do oxidation numbers or we can look at hydrogen. So let's cross out our coefficients there. This one we have 1 hydrogen to 2, so that shows a gain of hydrogen. And if we gain hydrogen, that means reduction. Let's also look at oxidation numbers because we can. On the left side, it's a +1. On the right side, that's its monatomic form, so it's 0. So a +1 to a 0. Our oxidation number has been reduced. And so that means that this is definitely reduction that's occurred here, because we've gained hydrogen and we've also gained electrons. Remember, things should always go hand in hand. They should always correlate. So your answer here, if you were to write it out, would be 2Al to 2Al with a 3 positive. And this is oxidation, or you can write oxidized. On this one, you'd have 6H plus going to 3H2. And this one is showing reduction, or you can say reduced. So that would be your answer, and that would be your answer. Okay, I hope that helps. All right, let's change gears a little bit. Let's talk about oxidizing and reducing agents. Before we get into the really specifics about this one, I want you to think about a travel agent. So let's say we have a travel agent and his name is Marty. And we go down to Marty and we say, hey Marty, we want to go on a trip to the Caribbean. And he's like, that's great. So what does Marty do as a travel agent? He schedules the trip, he plans the flight, he schedules different destinations we're going to go on, which resorts we're going to go to. But in the end, Marty doesn't come. So any kind of agent, whether it's a travel agent or maybe it's, James Bond, 007, or maybe it's Jason Bourne, whatever kind of agent they are, they're helping to do something. And this is exactly what's happening with oxidizing and reducing agents. Okay, so a reducing agent gets oxidized. So it's the substance that's oxidized. And the reason why this is a reducing agent is because it brings about reduction. So it's going to help the other substance become reduced, because remember, agents help. A very common substance that are reducing agents are metals. And notice I say usually because there are some exceptions. Okay, an oxidizing agent is the substance that gets reduced. So it's just opposite. Whatever's reduced is the oxidizing agent. And that's because whatever gets reduced is going to help bring about oxidation. So again, it's helping. Okay, this one helps bring about oxidation. And the most common oxidizing agents are usually oxygen, which kind of makes sense. Okay, let's do this problem down below. This problem down below, we're just going to ask, what are the oxidizing and reducing agents? So we need to go ahead and look at things. So right here, those both have copper. So what's happening here? We have oxygen on the left side, but not on the right side. So we have lost oxygen. And if we lose oxygen, that means reduction. Okay, then there's hydrogen, and we're going to compare that to the water because of the hydrogen. The hydrogen is the same, but notice how we have gained oxygen here. So gaining oxygen is oxidation. So now that we figured out what's oxidized and what's reduced, now we can figure out the agents. So right here, since this one's reduction, okay, it's the oxidizing agent. So I'm just going to put OA for oxidizing agent. Since this one is oxidation, that's the reducing agent. So I'm just going to put RA. So notice how they're just opposite. Okay, so in this case, the copper 2 oxide is undergoing reduction, and it's the oxidizing agent. The hydrogen in this case is undergoing oxidation, which is the reducing agent, because it's going to help the copper 2 oxide become reduced. That's why it's the agent. So just remember, it's oxidized. I mean, it's the opposite. Okay. All right, let's do another problem. Okay, this one. Some of the problems in your book are kind of wordy, and so I don't want you guys to get confused about this. So I chose one that would help with this. Okay, unsaturated vegetable oils react with hydrogen to form saturated fats. A typical reaction is the following. The question is the unsaturated oil oxidized or reduced, and is the hydrogen an oxidizing or reducing agent? Okay, we're going to do this just like we did the last problem. So first thing we're going to do is we're going to compare this lovely carbohydrate to this one. Okay, this is our unsaturated vegetable oil. This is our saturated fat. Okay, so here if we notice, carbon's the same, and that's not what we're looking at. We want to look at hydrogen or oxygen. Our hydrogen goes from 104 to 110. Okay, this shows a gain in hydrogen, correct? So if we're gaining hydrogen, we look down here, this shows reduction. Okay, our oxygen is 6 to 6. That stays the same, not a big deal. Okay, now let's look at this hydrogen. Because remember, if we have reduction, we have to have oxidation, but we want to double check. On hydrogen, we're going to get rid of that coefficient. We're looking at 2. This goes from a 2 to 110. There's nothing else to compare. It does gain oxygen, however. So on this one, if we say gain hydrogen, that means we're undergoing a reduction. But if we've gained oxygen, that means, oxidation. Okay, we have a problem here. We have two different viewpoints, and also both the reactants say that we're gaining hydrogen. Remember, when this happens, we need to look at a ratio. So, on this example, let's clear this out. Let's erase all this. Okay, let's start again. So let's go ahead and look at this. So when we're looking at this, we want to have a ratio of like 1 carbon to whatever else. So if we do a ratio here, we're going to have 1 carbon. And then what we're going to do is we're going to take this 104 hydrogen and we're going to divide that by 57 to figure out what the ratio is to 1 carbon. And the ratio here ends up being 1.82. So I'm going to put 1.82. That's our ratio of, so for every 1 carbon, we have 1.82 hydrogens. And then we're not worried about the oxygen here. So we're just going to leave that alone because it's the same. Okay. Then let's go to the other side. Again, we're going to do 1 for the carbon. And this time we're going to do 110 hydrogens divided by 57. And when we do that, the ratio is, it rounds to 1.93. Okay, so for every 1 carbon, we have 1.93 hydrogen. So now let's look at this viewpoint. If we look at this viewpoint, 1.82 and 1.93, this actually shows that hydrogen, that we've gained hydrogen. If we gain hydrogen, that shows reduction. Okay. Now let's compare the other element, the other reactant, sorry, right here, hydrogen. Again, cross out that 3. This time we have 2 hydrogen, and it's going to 1.93. That shows that we've lost hydrogen. And also we have no oxygen on that hydrogen, but on the product side we do. So we've also gained oxygen. Both of those viewpoints go with oxidation. So now we can be confident that this is correct because we have 2 different viewpoints. So again, let's look at the question. Is the saturated oil oxidized or reduced? Is the unsaturated oil, sorry. We know that's what this is, okay? So we can say, oh, we know what this is now. The unsaturated oil is reduced. And then it says, is the hydrogen an oxidizing agent or reducing agent? Well, we know that this is oxidized, so the opposite of oxidation is reducing. So this is the reducing agent because the hydrogen is going to help the unsaturated oil become reduced. So those would be your answers. I hope that helps. Let me know if you have any questions. On the announcement, it tells you which questions you can do from this video. And have a great day. Bye.